Remember, if that doesn't help you at all, then just keep them broken up. That would be our recommendation. When you're done, and when you're done only, don't follow along with me. I want you to do this on your own. When you're done with one, check your answers. Check mine too. So, yep. Oh, yep. See? That's why I got you.
And how many do you have left over? One, so you're gonna have one more.
So when you're done with both of them, check and see how you did. I am, thank you. That's why I got you guys. How did you do on number one? Is there any questions on how I got any of these answers for one? Any of these steps? Okay. So my recommendation, okay, when I do 8 times 6 in my head, it's 48. Okay, 48 is not a perfect square, so I would just keep it split up to help you out. Now, if you like the factor tree, then do the factor tree. Some people like to do it this method, and some people like to do the factor tree, whichever one works for you. Okay, if you like the factor tree where you just keep going, you can do it that way too. You can do 4 times 2, and 3 times 2, and break that down even more. Okay, then you have your pairs, and then that guy's left over. Either way works. If you like the square root method, go ahead. If you like the grouping method, that works too. Either one works. Okay, looking at number 2, do you have any questions on number 2? Remember, the goal is to have no radicals in the denominator. So if you end up with a radical in the denominator, then you need to relook at your work and see what you did wrong. Because the goal for this is just to get rid of the radical in the bottom. In order to do that, I must create another group of 5x. Because I need 2. Because the index is 2. Okay, whenever you multiply a radical by the same exact radical, it basically just disappears, and whatever is inside is going to be what's left over. Because technically you have 5x times 5x, and that's a group that comes out. Okay? Questions, comments, concerns on 1 and 2? You sure? Okay, now let's go ahead and finish up this notes here. So recall, the conjugate of a plus b, square root of b, is a minus the square root of b. Okay, so conjugate has that opposite sign in between. And the conjugate of a minus the square root of b is what? Yeah. Very good. Okay, that's going to help us now get that radical out of the denominator in some cases, because sometimes it's not just square root of 5x like we did over there. Sometimes it's 1 minus the square root of 5x. In order to get rid of it, we have to multiply what's called the conjugate. So state the conjugate for each expression, then multiply the conjugates together. So we're going to do that to see what kind of happens when we do it. So what is the conjugate for A here? Yeah, 3 minus the square root of 5. Okay, that's the conjugate. So that was step 1. Step 2 is to multiply it out to see kind of what happens. Does anyone kind of know what happens? Just maybe mathematically you just know that from previous classes? When you have the conjugates of each other? Well, let's find out then. All right, we got 3 times 3, which is 9. 3 times negative square root 5. Gamma. Beautiful. Yeah, negative 3 square root 5. Then we come underneath. Square root 5 times 3. Very good. Now, square root 5 times the same exact square root 5. What do you have left? 5. Okay, and let me explain that. Okay, try to get better at doing things like that pretty quickly. If I have a radical and I multiply by the same exact radical, it disappears and whatever was inside is now what it is. Because here's why. 5 times 5 is 25. The square root of 25 is 5. Okay, so mathematically that makes sense. All right, now if you notice something happens in the middle here, what? They cancel, okay? So when you multiply by the conjugate, the middles will cancel. That was kind of what I was looking for when I was asking you that question. It's okay if you didn't know right away. So now we just have 9 minus 5, which is? Beautiful. Okay, try the next one. Just the middle sign changes. Not that negative 2. Just the middle. That's how you do that. Okay. Very common. That's why it came up in my head. And the goal is to not have a radical when we multiply the conjugate. So if you end up with one, then you need to go back and check your answers. Slowly start to check your answers. See if you got the first step right. Did I do something wrong again? Oh, okay. So negative 2 times the radical 2. You can't multiply them together, so you just kind of have to express it like that. So negative 2 times radical 2x is like that. But here, a negative times a negative creates a positive. And that's why that's a US positive. You do, yeah, because negative 2 times this radical is just negative 2 times the radical of that. Yeah, you have it, there you go. Good. Okay. Yes. Yeah. Oh, is that what you were telling me? Yes, you were right. Guys, that's why I have you, you know. This is perfect. I like this. I like when you make corrections on me, because that means that you know what's going on. I do it on purpose, you know. Okay. So yes, there should have been 2's out there. Thank you. All right, but anyways, those cancel out, and I'm just left with the 4 minus 2x. I can't combine those, so please don't. That's your final answer. So with that being said, we could probably eliminate a step here. When you look at B, if I already know I'm multiplying by the conjugate, I really don't need to do those middle terms. If you want to give yourself a little bit of a shortcut, you can just multiply the first and the last. So this guy in purple and this guy in green. And these blue ones, you would not have to do in this situation. So if you're someone that could recognize you're multiplying by the conjugate, you don't have to do that every single time. And I'll show you what I mean by that in a second here. Okay, this one says, divide Rationalize the denominator using the conjugates, which is what we just did. So what is the conjugate of this denominator here? Yeah, 1 minus the square root of 2. It's the same thing as what we were doing yesterday, but now we kind of have one more step because we don't have just a square root 2 in the denominator like we did yesterday. But what I was saying about that trick, I'll show you how to do that now on the bottom. Again, the goal is to get rid of the denominator here. All I have to do is that first, 1 times 1, which is 1, and the last, square root 2 times negative square root 2. Negative square root 4, which is 2. Okay? So whenever you multiply a radical by the same exact radical, you have whatever is left inside. Okay? Because square root 2 times square root 2 is square root 4, and square root of 4 is 2. Kind of give you a little bit of a quick summary of why. Here, again, this is a whole group, so you have to apply the 3 to both. 3 times 1, yep, and 3 times negative square root 2 is 3 radical 2. We're almost done. All I gotta do is simplify this denominator, and what do I have left in the bottom? Yeah, negative 1. Oops, man, this pen. Okay, now you could leave it that way, but I mean, me personally, when you divide by a negative, that just changes all the signs. And I would just get rid of that somehow. So I would just go ahead and change all of the signs. So that negative 1 is now going to create a negative 3. Why is it doing that? A negative 3, it's going to create now a positive 3 radical 2. Okay, that's all I did is I applied that negative 1 to both of them. Cool? All right, not too hard. Okay, you're going to get better at it. Let's look at the next one. Why don't you try to give that one a try, see how you do, because it's just like the one we just did. Try to use mine as a guide and see if you can at least get one step. Maybe that's as far as you can get, that's fine. But at least you're getting more progress than you had from the beginning of the notes. Okay, go ahead and check and see, check my work too, because division's not a strong suit. Okay, now if you got to this step, good job, awesome. However, you could simplify all of them. Okay, every single piece can be divided by 2. Okay, in order to reduce, all 3 of them have to be able to do that. All three of these pieces can be divided by 2 to reduce it. If you got to this step, good job. However, we would like you to keep going. Okay? Is there any questions or is there any errors in my work? Yes.
Do you always, like, for the second
It is actually it's most likely, yes, it's always going to be negative, only because when you have a conjugate, they're always opposite signs. So yes, you should be ending with a negative, yeah. Yep.
Conjugate is 17.
17. What's 34 divided by 2?
17.
Okay, so if you want to make a note for yourself, on your notes, you can just be like, oh, this is what Miss Abel did in her notes. She divided by 2, and that's how she got that answer. I divided each piece by 2. All right, almost done. All right, here we go. Last one. Ooh, this one looks very fun to me. Okay, remember, you're taking the conjugate of the denominator because the goal is that the denominator has no radical. So some people, what we see on an exam is they'll do 2 plus the square root of 3. But that's not what we want to do. We want to get rid of the denominator. So what am I going to multiply the top and bottom by?
7 minus
Yeah.
5.
Okay. All right, this one get a little tricky. So let's just do the denominator first because I know that's the easy part. So I just do 7 times 7, which is, yep. And then square root 5 times negative square root 5. Yep, which is negative 5. Very good. Okay, if you're wondering, I'm going to write maybe a little work on this one step here. This technically is radical 25, and that's how I'm getting this 5, in case you're wondering why. Because 5 times 5 is 25, and that's how I'm getting that 5. But hopefully you start to realize that when you multiply a radical by the same exact radical, it's whatever's inside is your result. Okay, so trying to get you to get some shortcuts in here. Now, this one is not as pretty because they're not conjugates. This has a 2, this has a 3, this is a radical 3, this is a radical 5. So we can't do that shortcut method that I just showed you. You have to do all of them. You have to distribute completely. Okay, so let's take time to do that. 2 times 7, which is 14. Okay, then I have 2 times negative square root 5. Beautiful. Okay, then I have negative square root 3 times 7. Good, I like how you guys are saying it correctly too. And the very last one, in black, negative square root 3 times a negative square root 5. Yeah, good. Wait, did you say negative square root 15? Oh, positive, right? So positive square root 15. I think my brain was making things up in my head. Okay, so this is where we are. Do you have questions on any of these ones on top? You can tell me the color and I'll explain it. Yes?
For the 7,
Yeah.
square root 3,
Yeah.
the negative is always in front of the number?
Yes.
Okay.
Yep.
So it's never going to be like 7 minus square root.
No, yeah. They're attached. When you're multiplying, the 7 is applied right in front of it. Okay, question. Okay, do you have any questions on that one step? We're almost done here. Okay, so now we can reduce as much as we can here. So I definitely can simplify the denominator. What do I get? 44 on the bottom. Awesome. Okay, now let's talk about this one. You might want to do some side work. That 14 is alone. He is just kind of hanging out, so I'm going to put him there just for the sake of knowing I have nothing to do with it. However, let's kind of just go up on top of the 15 and see if we can reduce this in any way. Am I going to be able to reduce 15 at all? No, okay, never mind. We're not going to go and do that then. So really, I just have what I have. I can't add or subtract anything unless they have the same exact radical, which I do not. Okay, so this is what you get. There's nothing I could do. Okay, there may be an instance where that would have reduced or simplified and you could have done something. But if that's the case, don't try to do more work for yourself and try to figure it out. I mean, we can't do anything. Our goal is to not have a radical in the denominator because we just mathematically can't have that. Okay, so Ms. Marquez is giving you your homework. Okay, you have a lot of time. You should be able to finish it. It is a Friday, so hopefully you can finish before you leave. Like always, the front page is what we just did. Oh, no, it's not. The back page is what we just did. So, this is well, this is why we're giving you about 26 minutes. Okay. 1 through 18 is all review. The only thing that's new is 19 to 21 in the back. Yes, it looks like a lot, but that's why we're giving you a lot of time to do it. Okay? We're doing this because your test is coming up next week and you need to keep practicing the skills that we have been doing this whole chapter, okay, since the beginning of January.
Think about it this way. This is a mini review for you. We did this all week. So if you have questions on this now's the time to ask before we get into new material on Monday.
Well, I got 2 more lessons and then we'll review and then we'll test out.